Okay. Good afternoon to one and all. This is Gopi Krishna, Assistant Professor, Department of Computer Science and Engineering from Chevrolet Engineering College. Subject is compiler design. So today we want to discuss about what is the syntax directed translation and how to construct the syntax tree. So in previous class we want to discuss about the evolution of a syntax evolution of an expression or annotated parse tree for the given expression. Okay. So in this class we want to discuss about this class we want to discuss about what is the syntax directed translation and construction of a syntax tree. Okay, 1 minute. Okay, so here the syntax directed translation and the construction of a syntax tree. So in this syntax directed translation. So what is the definition for syntax directed translation? And it is similar to the syntax directed definition. So what is the definition for say SDD? So here we are having the context-free grammars that are associated with semantic rules. That is the syntax-directed definition. So coming to syntax-directed translation. So here in this SDT is same as SDD. Okay. So syntax-directed translation is same as syntax-directed definition. That is context-free grammar plus semantic rules. So that is the definition for syntax directed definition. So in this syntax directed translation is also same as the syntax directed definition. The difference is the semantic actions, and we can place the semantic action at any position of the right hand side, and the semantic actions are specified in curly braces. Okay. So what is the difference between syntax directed definition and syntax directed translation? Means in syntax directed definition we are having only context free grammars associated with semantic rules. So in coming to syntax directed translation, so here we are having context free grammars plus semantic rules, and those semantic actions we can place at the right hand side, anywhere of the right hand side. Those semantic actions that can be used by using curly braces. Okay, so the only difference is that is the difference. We can place the semantic actions. We can place the semantic action at any position of right hand side, and the semantic actions are specified in curly braces. So for example, we are considering one example: X produces Y Z. Okay, so this is the production. So we are using the syntax directed translation. So X produces, here we are performing the action, semantic action, or here we are performing the semantic action, or end of the production we are performing the semantic action. So anywhere we want to perform the semantic action. So the semantic action can be represented by using the curly brackets. So ఇక్కడ ఈ రైట్ హ్యాండ్ సైడ్ ఎక్కడైనా మనం ఈ సిమాంటిక్ యాక్షన్ ని ప్లేస్ చేయవచ్చు అని చెప్తాడు. సో దట్ ఈస్ ద ఓన్లీ డిఫరెన్స్ టు సింటాక్స్ డైరెక్టెడ్ డెఫినిషన్ టు సింటాక్స్ డైరెక్టెడ్ ట్రాన్స్లేషన్. ఓకే, ఇస్ ఇట్ క్లియర్? Anyone? Is it clear? The syntax directed translation is same as the syntax directed definition. That is context free grammar plus semantic rules. That is called the syntax directed definition. And we can place those semantic action at any position of right hand side. So ఈ పొజిషన్ లో ఎక్కడైనా మనం ఆ సిమాంటిక్ యాక్షన్స్ ని మనం ప్లేస్ చేస్తే దాన్ని సింటాక్స్ డైరెక్టెడ్ ట్రాన్స్లేషన్ అని చెప్తారు. ఓకే, సో హియర్ we are considering one example. We have to understand what is the difference between syntax directed translation or syntax directed definition. Okay, so here translation scheme to convert a infix expression to postfix expression. So what is infix expression and what is postfix expression? So first of all, what is an expression? So expression is a combination of operators and operands. That is called the expression. What is infix expression? What is infix expression? Anyone? What is infix expression? The operator is
Operator is in the middle.
placed at the middle of the operands.
Operands.
సో ఆపరాండ్స్ మధ్యలో కనుక మనం ఆపరాండ్స్ మధ్యలో మనం ఆపరేటర్ కనుక ప్లేస్ చేస్తే దాన్ని ఇన్ఫిక్స్ ఎక్స్ప్రెషన్. వాట్ ఈస్ ద పోస్ట్ ఫిక్స్ ఎక్స్ప్రెషన్? ద ఆపరేటర్ ప్లేస్డ్ ఎట్ ది ఎండ్ ఆఫ్ ది at the after the operands, that is called the postfix expression. So here we are using the translation scheme to convert a infix expression to the postfix expression. So in this syntax directed translation we are having two methods. Okay, so coming to, let us take the method 1. So here we are having the expression 2 plus 3 star 4. So in this we are having two operators. So one is plus and one is star. So ఇలా two operators వచ్చినప్పుడు మెథడ్ 1 తీసుకుంటాం. అదే సేమ్ ఆపరేటర్స్, సో 2 ప్లస్ 3 ప్లస్ 4 తీసుకున్నారు అనుకోండి, సో దట్ ఈస్ కన్సిడరింగ్ యాజ్ అ మెథడ్ 2. ఓకే, సేమ్ ఆపరేటర్స్ వచ్చినప్పుడు ఎలా కన్స్ట్రక్ట్ చేస్తారు, ఈ కన్వర్షన్ అనేది జరుగుతుంది బై యూజింగ్ సింటాక్స్ డైరెక్టెడ్ ట్రాన్స్లేషన్. అండ్ సేమ్ ఆపరేటర్ వచ్చినప్పుడు ఎలా జరుగుతుంది అనేది చూస్తాం. ఓకే, సో ఇన్ మెథడ్ 1 వీఆర్ హ్యావింగ్ ద ఎక్స్ప్రెషన్ 2 ప్లస్ 3 స్టార్ 4. ఓకే, so in previous class we are going to write a productions with semantic rules. Okay, semantic rules రాశారు. ఒక ఎక్స్ప్రెషన్ బేస్ చేసుకొని దానికి ప్రొడక్షన్స్ యాజ్ వెల్ యాజ్ సిమాంటిక్ రూల్స్ అనేవి రాశారు. ఓకే, సో మనకి ఇలా ఇచ్చిన ఎక్స్ప్రెషన్ కి సో ప్రొడక్షన్స్ ఏం తీసుకుంటాం, అలాగే ఆ సిమాంటిక్ రూల్స్ ఏంటంటే ఇవి చూడండి. సో హియర్ వీఆర్ హ్యావింగ్ ఇన్ దిస్ ఎక్స్ప్రెషన్ వీఆర్ హ్యావింగ్ ద plus operator and star operator. So we are considering the production E produces E plus T. Okay, so what is the semantic action? So here we are having the semantic action is print. So what is the symbol here? Plus. So within the single quotes we are using plus operator, semicolon, and we are using the curly brace. So it is the only difference in syntax directed definition to syntax directed translation. So in this syntax directed definition we are using e dot value is equals to e1 dot value plus t dot value. So that is the semantic rule for this syntax directed definition. So in this syntax directed translation we are using the semantic action within the curly brace. So we are converting infix expression to postfix expression, then we are writing postfix. So end of the production we are writing the semantic action. So that is the print plus in curly brackets. Okay, so that is the difference in syntax directed translation with syntax directed definition. Okay, so we are having plus, so we are using print plus within the single quotes we are using curly bracket, we are using semantic action. So why? Because we are taking this production. So in this expression we are having plus and star, then only we are writing the expression is E produces E plus T, then E produces T. Is there any semantic rule? So in syntax directed definition we are using E dot value is equals to T dot value. So it is only just the assigning operator, so there no need to perform the any semantic action. So we are not performing any semantic action here, just we are assigning t with t to e only. So there is no semantic action in this one. Okay, then in this expression we are having the asterisk symbol, so multiplication operator is available, then we have to take the production with multiplication. So the production is T produces T star F, and what is the semantic action here, and multiplication operator is there, then we are printing star. Okay, so that is the semantic action. So we are writing, and next production T produces F. So here we are using F is assigned to T only. So there is no need to perform any semantic action. Then F produces num. So here F produces num means so it is a value. So it is a number. So we are using to perform the semantic action, that is print num dot value. So a particular number ki ento konta value untunda. So that value can be printed. Okay. So this is the semantic action for this one. So is there any productions along with this one? So there is no production. Why? Because already plus is getting and star is getting. There is no operator in this one. So for example, in this expression we are having 2 plus 3 star 4 minus 4 అనుకోండి. Okay, 4 minus 4 ఇచ్చారనుకో minus. So we are using E produces, so E minus T also we are writing the production. Why? Because so is there any operator that is present in our expression? Then we have to construct, we have to take the production within the operator only. Okay, so this is the construction of productions and semantic actions. So we are having these productions. So then only we have to construct the parse tree. So parse tree ni construct chesesi aa parse tree ni base cheskoni we are converting infix expression to postfix expression. Okay. So we are using this this expression. We have to convert a parse tree. Okay. So by using this expression, we need to write the parse tree. Okay, so here we have to construct the parse tree. We are using the first production. What is the first production here? So E produces E plus T. Okay, E produces E plus T is the production, and this is also one value. So here E produces E plus T and print plus is the 1. So here we are using this one also we are using. Okay, E produces E plus T and print. So semantic action we are performing within the variables only. Okay, so print. Next, here what is the next one? So 2 plus 3 star 4. So we are constructing a parse tree based on the expression. So based on the expression, we are constructing the parse tree. So here plus is getting. Then this E is uh, not using with multiplication. Why? Because so with the production E is having only plus symbol, plus operator. There is no star with E. So then only we need not to expand this E into next production. So T produces T star F. So we are expanding T is with T star F. So E produces T. So then we are using E produces T with this one, and here T. So for example, in this T, we are having two productions. T produces T star F and T produces F. So which which production we are using to construct the parse tree? So we are considering this one. So T produces T star F. We are using this one. So star is getting here. So we are having 2 star 3 plus 4. So then only we are considering this production. So here is the expression is 2 plus 3 star 4. Then only we need to expand T produces T star F. Then we are writing just T produces F. So T produces F and F produces num. And what is the production? So semantic rule, F produces num. So print num dot value. So what is the value of num dot value? So here first we are using 2. So 2 plus, then next one T. So T produces, what is the productions of T produces T star F and T produces F. So we are using T produces T star F. So we can get the expression, but we are using this production T produces F. Then we are using only 3, not star 4. Then we are taking the production as T produces T star F. So here T produces T star F, and what is the semantic action? Print star. So this is the semantic action. Then next one. So this row is completed. Then we are converting. So we are getting num2 plus. So here we are getting the number and star, and here we are having number. So no need to expand. T produces T star f again. Why? Because in our expression we have only one multiplication operator. Then only no need to expand the T produces T star f. So we are just expanding T produces f, and f produces num. So num dot print num dot value is 3. Okay. Then star f. So f produces number. So print num dot value. So what is the value of last one? 4. So here 2 plus 3 star 4. So this is the given given expression for the pass tree. Okay. So ఇచ్చిన expression కి ఇది pass tree అవుతుంది. Okay. Is there any doubt with this pass tree? So we are having E produces E plus T. We are adding the semantic action to the pass tree also. And E produces T, T produces F, and F produces num. And here we are having T produces T star F and semantic action. So we are considering 2 plus 3 star 4. That is the given parse tree for the given expression. Okay. For this expression, we have to construct the parse tree based on in our expression. So this is the parse tree. Then what is the translation scheme to convert infix expression to postfix expression? So after constructing a parse tree, then we have to convert that parse tree into postfix expression. So postfix expression ఎలా కన్వర్ట్ చేస్తారంటే చూడండి. So here is the parse tree. So in syntax directed definition, we are using top to bottom and traversal. We are using top to bottom and left to right traversing. We are using that concept. If there is any reduction, so we have to perform the corresponding semantic action. Okay. So that one is right. So we are using top to bottom and left to right. We are using, and is there any reduction, we need to place that particular semantic action to that particular one. Then we can get the enumerated parse tree in syntax directed definition. So here we are converting a infix expression to postfix expression by using translation scheme. Okay. So in syntax directed translation. So here we are using top to bottom. So we are getting in this way. So here num. So print num dot value. So what is the num dot value here? 2. So we are using to print 2 here. Then we are moving left to right. So here plus. So there is no production with E produces E plus. So then we are moving down, and so here num dot. So num print num dot value. What is the print num dot value is 3. So we are using print statement. So we have to print that particular num dot value. So we are printing 3 here. Then we are moving up, and so here T produces T star. There is no production with T produces T star. Then we are moving downwards, and here num print num dot value. What is the num dot value here? 4. We are using to print 4. Then moving up. So here we are moving upward. So in this way we are moving upwards. Then what is the value here? Print star. So then print star, and we are moving top. So print plus. So this is the conversion of a infix expression into postfix expression by using the syntax directed translation. Okay. So is there any doubt? Anyone? 61.
No, sir.
Okay. So here in this
Sir.
Amma.
పిలిచారు సార్
Huh?
పిలిచారు కదా సార్ 61 అని
Doubta?
లేదు లేదు సార్.
Right. Okay. So in this parse tree, we have to construct in conversion of infix expression to postfix expression. So in syntax director definition, we are moving top to bottom and left to right. So we are moving in this direction. So first we are printing 2, then here we are moving next 3, and there is no star. Okay. So T star F తో T star తో ఏమి ప్రొడక్షన్ లేదు కాబట్టి మళ్ళీ డౌన్వర్డ్ అండ్ 4 ప్రింట్ అయింది. సో ప్రింట్ అని రాసినప్పుడే ప్రింట్ అవ్వాలి. సో ఇస్ దేర్ హియర్ స్టార్ వచ్చిందని స్టార్ ని ప్రింట్ చేయడానికి లేదు. సో ప్రింట్ అనే ఆప్షన్ ఎక్కడైతే వస్తుందో ఆ ప్రింట్ ఆప్షన్ దగ్గరే మనం ఈ ఈ అవుట్పుట్ అనేది మనం ప్రింట్ చేస్తాం. సో ఫస్ట్ 2 ప్రింట్ అవుతుంది, తర్వాత 3, తర్వాత వచ్చేసి 4 అండ్ నెక్స్ట్ స్టార్ అండ్ ప్లస్. ఓకే, సో దట్ ఈస్ ద conversion of infix expression to postfix expression. So top to bottom and left to right, we are using the traversing. Okay, so 2, 3, 4 star plus. So this is the postfix expression for this given expression 2 plus 3 star 4. So is there any doubt with this conversion? So we have to solve infix expression to postfix expression, that is available in formal languages in ఆటా బెటా థియరీ. సో ఒకసారి మీరు చెక్ చేసుకున్నారనుకోండి, మీకు ఐడియా వస్తుంది. ఓకే, then so this is the example. So this is method 1. So what is method 2? Already told first method 1 is we are having different operators. In method 2 we are having same operators. So same operators we have to convert a infix expression into postfix expression by using the syntax directed translation. So we are considering this one 1 plus 2 plus 3. So this is the given expression. Then we have to convert this infix expression to postfix expression by using this one. So here productions and semantic rules. So in this one productions we are having only plus, only one operator. Then only we are writing e produces e star e plus t. There is no need to write t produces t star f. Why? Because in our expression we are having only one operator only. Then so e produces e plus t and t produces num value. So these two productions are we are using. Then so we are converting this infix expression to postfix expression. So the given production e produces e plus 3 and print plus with semicolon or t. So e produces t also. E produces e plus t, print star. This is the semantic action, and this t also we e produces t also. So in this expression it is in the form of a produces a alpha or beta. Okay, so here we are having the left recursion. So then we are in our productions we are getting a left recursion. So we have to eliminate that left recursion. So how to eliminate the left recursion? The production is in the form of a produces a alpha or beta. Then the productions are a produces beta a dash and a dash produces alpha a dash and epsilon. So these are the productions. So in our productions, the productions is in the form of left recursive productions. We have to eliminate the left recursion by using the following rules. Okay, so what are the rules here? We are having the production a produces a alpha or beta. Then we are having a produces beta a dash and a dash produces alpha a dash or epsilon. So this is the elimination productions for this statement. Then we are eliminating the this left recursion to this production. So e produces e, the remaining part is alpha and t is the beta. So we are eliminating this left recursion. A produces a alpha means a produces beta. So where beta is capital T. So E produces T. Here A dash we are using remaining part. So remaining part ni ఇలా రాస్తున్నాము. సో R అనేది రిమైనింగ్ పార్ట్ కింద ఇస్తున్నాం. సో E produces beta A dash. సో A dash రాయకుండా సో వీఆర్ యూజింగ్ రిమైనింగ్ పార్ట్ R అని తీసుకున్నాము. సో రిమైనింగ్ పార్ట్ A dash ప్రొడ్యూసెస్ ఏమవుతుంది? ఆల్ఫా A dash అవుతుంది. So or epsilon అవుతుంది. So here we are using R produces. So what is alpha? Plus T and curly braces open print plus semicolon curly braces close and A dash. So A dash అంటే R తీసుకున్నాం. So here R A dash produces alpha A dash. So plus T print plus and R. So this is the our production and R produces epsilon also. So what is the remaining production? T produces num. So T produces num, print num value. So in this R produces epsilon, there is no only assigning epsilon to R, and here we are using T produces TR, R produces plus T and R. Okay. So these are the productions after eliminating the left recursion. So in method 2 we are having in method 1 and method 2 we are having the left recursive productions. Then we have to eliminate. So left recursion వచ్చినప్పుడు మనం ఎలిమినేట్ చేసుకుంటాం. సో ప్రీవియస్ దాంట్లో కూడా లెఫ్ట్ రికర్షన్ ఉంటుంది, బట్ డిఫరెంట్ సింబల్స్ ఉంచినాయి కాబట్టి నో నీడ్ టు convert the eliminate the left recursion. Okay, so in this method we are having same symbols, we have to eliminate the left recursion. So here after eliminating the left recursion we are getting these productions. So we have to construct the parse tree here. So how to construct the parse tree? So what is the first production in this one? So we have to write those production. E produces T capital R. So E produces T capital R. So what is the production here? What is the expression here? 1 plus 2 plus 3. So then only we are writing. So T produces num only. In this T we are having only one production. So T produces num, print num dot value. So T produces num, print num dot value. So that is 1. Then only we are producing R. So R produces plus T, print and R. So we are having this one, this one, this one, this one. So 4 is having. So plus T, print plus and R. Okay. So plus is getting. So 1 plus T produces only one production. Num, print num dot value, that is 2, and print plus we are having one value and R. So again R we are converting. So R produces two productions. So R produces plus T and R produces epsilon. So we are using this one. So this expression is not satisfied. Why? Because again we are getting one more plus. So then only we are considering this production. So R produces plus T, print and R. So we are having this R with epsilon and T is having 3. So 1 plus 2 plus 3. So this is the given expression. This is the given. We have to construct the parse tree. So this parse tree we have to convert a in-fix expression to postfix expression. So what is the rule to convert a in-fix expression to postfix expression? We are moving top to bottom and left to right traversing. Okay, we are having E. So this is the way we are moving. So 1. So we are using. So 1 was in print num dot value. We have to print this value. So 1, and we are moving this way. So here we are getting plus. So we can print this plus or not. So we are not printing this plus. So only we are getting the print that statement. Then only we have to print that symbol only. Okay. So plus here num. So print num dot value. Then we have to print num value, and we are having print here. So num తర్వాత ఇక్కడికి వెళ్ళింది కదా, సో ఇక్కడ print the plus. So we are having print the plus, then moving this way. So here we are having print 3, then we are moving this way. So here we are having print plus only we are printing this one, and finally we are moving this way. So epsilon. So after plus we are printing epsilon. So it is not necessary to print the epsilon. So this is the conversion of given expression into postfix expression. Okay, so you have to check with conversion of infix to postfix by using flat. Okay, is there any doubt with these two examples? Anyone? Hello? No one. So next one, construction of a syntax tree. So how to construct a syntax tree? So what is the definition for the syntax tree? So in general, we are using syntax tree. So in this construction of syntax tree, so in a syntax tree, internal nodes are operators. So operators ni internal nodes కింద తీసుకుంటాం. Internal nodes means with including root node, remaining nodes. సో ఏ నోడ్ కి అయితే మనకి చిల్డ్రన్స్ వస్తాయో వాటిని ఇంటర్నల్ నోడ్స్ అంటారు. చిల్డ్రన్స్ వచ్చి మళ్ళీ చిల్డ్రన్స్ నుంచి దెర్ ఇస్ నో చైల్డ్స్. సో అలాంటి నోడ్స్ ని లీఫ్ నోడ్స్ అంటారు. రైట్. So in a syntax tree, internal nodes are operators and the leaf nodes are operands. So ఈ సింటాక్స్ ట్రీ ఎలా ఉంటుందంటే ఇంటర్నల్ నోడ్స్ అనేవి ఎక్కడ వస్తాయంటే ఆపరేటర్స్ ని ఇంటర్నల్ నోడ్స్ కింద తీసుకుంటాం. రిమైనింగ్ లీఫ్ నోడ్స్ అనేవి ఆపరాండ్స్ కింద తీసుకుంటాం. సో ఆపరేటర్స్ అంటే ఏంటి? ప్లస్, మైనస్, స్టార్, డివిజన్ ఇవన్నీ ఆపరేటర్స్. సో దోస్ ఆర్ కాల్డ్ ద ఇంటర్నల్ నోడ్స్. అండ్ ఆపరాండ్స్ అంటే A, B, X, Y, Z like that we are having the operands. So those are having the leaf nodes in this construction of a syntax tree. So in order to construct a syntax tree, three functions are used. So what are the three functions we are using? So first one, make node. Okay, and second one, make leaf, and third one also make leaf function. These three functions we are using to construct the syntax tree. Okay, so what is make node? So make node, we are having three arguments. What are the three arguments? OP, operator, left, comma, right. So operator, so we are using OP as the argument name. So that is the operator. And what is the left? So we are assigning the address of left child. Okay, we are using left means the address of left child, and we are using right. So it is we are using address of right child. Okay, so this is the make node function. And what is the make leaf? So make leaf means we are having two functions with make leaf. So first one is ID. So it is an identifier. What is an identifier? It is like a uh, it is like so a variable value. ID means a variable values, and this another argument is entry to the symbol table. So this is second function. And what is the third function? Make leaf. Make leaf. So in this make leaf, so we are having two arguments. So first one is num, and second argument is value. So here we are considering the number means it is a constant value. Constant value. So what are the constants having? 1 to infinity, we are using the constant values 1, 2, 3, 4, 5, and so on like that. We are using the num and value. Okay. So these three functions we are using to construct the syntax tree. So first one, what is the make node function? So make node function, it is useful to create a node with operator field. So operator ఉంటుంది కదా, ఆపరేటర్ తోనే మాత్రమే మనం ఈ నోడ్ ని క్రియేట్ చేస్తాము. In this operator is called the internal node. So ఇక్కడ ఆల్రెడీ చెప్పాను కదా, internal nodes are said to be a operators, and leaf nodes are having the operands. So we are using to create a node with operator field. Okay, so mk node, so op comma left comma right. So op means operator, and left means left child address, and right means right child address. And second one, make leaf function. So what is the second function? Make leaf. So make leaf function, we are having two arguments. First one is ID, and second one is the entry to the symbol table. So ID means we have identifier, and entry to the symbol table means the address of the this identifier we are specifying this argument. Okay, so mk leaf, so id means identifier, and entry to the symbol table means address of that identifier. Okay, next one, make leaf function. So make leaf function, so we are having num comma value. So we are having two arguments, num comma value. So here it is a constant value like 10, 20, 30, 1, 2, 3, and so on, like that. We are having num, and value means వాల్యూ ఆఫ్ దట్ నంబర్. సో మనం ఏదైతే నంబర్ తీసుకున్నామో ఆ నంబర్ కి వాల్యూ ఉంటుంది కదా. ఫర్ ఎగ్జాంపుల్ కాన్స్టెంట్ 10 తీసుకున్నాను అనుకోండి, num comma 10 we are specifying mk list. Okay, so these are the three functions we have to construct the syntax tree. Okay, so first one, let us consider one example, construction of a syntax tree for x star y minus 5 plus z. So this is the given expression, so we have to construct the syntax tree for this expression. Okay, so how to construct the syntax tree? So we are using three functions how to construct the syntax tree. So what are the three functions here? mk node, mk leaf, mk leaf. So mk node having op comma left comma right, mk leaf having id comma entry to symbol table, and mk leaf number comma value. So these three functions we are using to construct the syntax tree. Okay, so uh, steps for construction of syntax tree for x star y minus 5 plus z. So we are having two fields, symbol and operation. So what is the operation we are performing? So symbol operation. So let us consider this one. So this is the given expression. So we are considering from left to right. So first symbol is x. So x we are using symbol, and so x is the operator or operand? X is an operator or operand?
Operators.
Operand, operator, x.
Operand.
Operand. So x is an operand. Then we are using these two functions. So make leaf. So make leaf. రెండు functions ఉన్నాయి. అందులో ఏ function యూజ్ చేయాలి? Make leaf function. Why? Because it is an identifier at a number. So we are using this function mk leaf. So mk leaf id comma entry to x. సో మనం తీసుకున్న ఆపరెండ్ ఏంటి? మనం ఎంట్రీ టేబుల్లో సింబల్ టేబుల్లో రాయడానికి యూజ్ చేసేది ఏంటిది? ఎక్స్ కాబట్టి, సో ఐడి కామా ఎంట్రీ టు ఎక్స్. సో దిస్ ఆపరేషన్ వీఆర్ స్పెసిఫైయింగ్ p1. సో p1 అనేది ముందు స్పెసిఫై చేయకూడదు. సో మేక్ లీవ్ ఫంక్షన్ రాసేసిన తర్వాత ఈ మొత్తం ఫంక్షన్ ని ఆపరేషన్ ని మనం ఈ p1 కి అసైన్ చేస్తాం. ఓకే, నెక్స్ట్ వీఆర్ యూజింగ్ y నాట్ స్టార్. సో we are reading the values first x, y, then only we are performing xy operation. Then next 5, then we are performing this one. Next z, then performing plus. Okay, so we are having next y. So y is an operand. Then we are using make leaf id comma entry to y. Entry to y. Then we are using y as the operand. We are using make leaf function id comma entry to y. So identifier. So what is the identifier here? Y. Okay, so the total function we are specifying the name is p2. Then we are considering this one, so star. So star means so this is x, so this is y. So in this one x ki left child అవుతుంది, ఈ y అనేది స్టార్ కి రైట్ చైల్డ్ అవుతుంది. సో స్టార్ కి x అనేది లెఫ్ట్ చైల్డ్, y అనేది రైట్ చైల్డ్. సో వీఆర్ యూజింగ్ స్టార్. స్టార్ యూజ్ చేస్తే అదేంటిది? ఆపరేటర్. సో విచ్ ఫంక్షన్ వీఆర్ యూజింగ్? మేక్ నోడ్ ఫంక్షన్. సో మేక్ నోడ్ ఫంక్షన్ యూజ్ చేస్తే mk node star. Star means operator, comma what is the left child address? Left child is x. So what is the address for left child? p1, comma, and what is the right child? y. So that is we are saving in p2. So p1 comma p2 we are using this one. So make node of star comma left child address is p1 and right child address is p2. So then this function we are specifying the P3, and this function we are specifying P3. Now we are considering 5. We are considering 5. Then which function we are using? So the function we are using make leaf num comma value. So number means it is a constant value. So we are using this function make leaf num comma. What is the value of that particular number? 5. So here we are specifying 5 is the number. Okay. Then we are specifying total this function to the P4. So next we are performing subtraction. So 5 అనేది ఉంటుంది. Okay. So subtraction we are taking the symbol subtraction. Then this is a operator. So which function we are using? MK node. So operator comma left comma right. So operator means we are having minus, and what is the left child for minus? సో మైనస్ కి లెఫ్ట్ చైల్డ్ ఎవరున్నారు? ఎక్స్ స్టార్ వై. సో ఎక్స్ స్టార్ వై అనే ఆపరేషన్ ఎక్కడ పర్ఫామ్ చేసాము? ఈ P3లో పర్ఫామ్ చేసాము. సో వీఆర్ కన్సిడరింగ్ P3 యాజ్ ద లెఫ్ట్ చైల్డ్, అండ్ హియర్ వీఆర్ యూజింగ్ 5 in P4. So we are considering left child address is P3 and right child address is P4, right? Then so minus complete. Next we are considering Z. So we are considering the Z value. So Z, so we are using, so Z is an identifier. We are using the function make leaf. So mk leaf id entry to Z. So total this function is initialized to P6. So what is the next one? Plus. So we are specifying the symbol is plus. So we are using the function is make node function. So make node of plus. So total P5. సో P5 అంటే ఇది మొత్తం ఇక్కడ దాకా ఎంత అయితే ఉందో ఇది మొత్తం P5 లో ఉంది. P5 కామా P6. సో P5 is the left child address and P6 is the right child address. So this is the steps we have to construct the syntax tree for the given expression. We are using symbol and operation. So P1, P2, P3, P4, P5, P6, P7. సో ఇక్కడ ఎన్ని అయితే ఎక్స్ప్రెషన్ లో ఎన్ని సింబల్స్ ఉన్నాయో అన్ని ప్రొడక్షన్స్ అనేవి వస్తాయి. P7 దాకా వచ్చింది. ఓకే. సో ఇది కన్స్ట్రక్ట్ చేసిన తర్వాత వీ హ్యావ్ టు రైట్ ద సింటాక్స్ డైరెక్టెడ్ డెఫినిషన్. సో వాట్ ఈస్ సింటాక్స్ డైరెక్టెడ్ డెఫినిషన్? We are having the we are having productions as well as the semantic rules, that is called the syntax directed definition. So in this the given expression is x star y minus 5 plus z. Then this is the expression. We have to write the productions here. So in this one we are having 3 operators. So we are using the productions is E produces E1 plus T, and E produces E1 minus T, and E produces E1 star T. So ఆపరేటర్స్ ఏవైతే ఉన్నాయో అవన్నీ మనం ఇక్కడ E produces E plus T, E produces E minus T, E produces E1 star T, and E produces empty. So E produces T అనేది empty, and T produces ID. So we are having identifier also. X, Y, Z are the identifiers, and so that T produces ID and T produces num. Why? Because so here we are having the in our expression we are having number also. So these are the productions. E produces E1 plus T, and E produces E1 minus T, and E produces E1 star T, E produces T, and T produces ID. So we are using T means so we have to write this one. So E produces T, and T produces ID, T produces num. So here we are having the production. So what are the semantic rules here? The semantic rules is so E dot node. So we are using dot value. Value is the attribute value. So in this one we are having the node values. So node means we are constructing a syntax tree. So it is in the form of node. Then only we are considering the object attribute name is node. So E dot node is equals to. So here we are having the plus operation. So we are using which function we are using constructing operator. So we are using make node operator. Okay. So make node. So what is the first one? plus, and here E1 dot node comma T dot node. So here is the E1 is the left child address and T is the right child address. So E dot node is equal to MK node plus comma E1 dot node comma T dot. So here is the operator left child address, right child address. So in the same way we are using E produces E1 minus T. So E dot node is equal to MK node. Why? Because we are having the operator here. So MK node minus, this is the left child address, this is the right child address. Same, E produces E1 star T. So E dot name node is equals to MK node of star E1 dot node comma T dot node. So this is the left child address, this is the right child address. So here E produces E dot T. So E dot node is equal to T dot node. So T dot node. So here T dot node. So here it is the identifier. We using the make leaf function with identifier. So this function we are using. So T dot node is equals to make leaf of identifier ID comma. So ID dot entry. So this is the entry to the symbol table, and T produces num. So T dot node is equals to MK leaf of this function. So num comma num dot value. So number ఏదైతే ఉందో ఆ వాల్యూని ఇక్కడ స్పెసిఫై చేస్తాం. So this is the construction of a syntax directed definitions for the given expression. So this is the given expression. We are constructing the syntax directed definition. So in our expression we are having three operators. Then only we are writing the expressions productions. Here E produces E plus T, E minus T, E star T, and E produces T, and T produces ID, T produces num. So this is the construction of syntax directed definition. Then final first step is we are constructing a symbol with operation, and second step is syntax directed definition, and third step is we have to construct the syntax tree. So what is the construction of syntax tree here? So here is the syntax tree. So what is the P1 here? So what is the production one? So P1 MK leaf of ID comma entry. So in how many arguments here? Two arguments, ID comma entry X. So we are using in this so two, in a node we are having two fields. So ID comma entry X. So in P1. So second P2 ID comma entry Y. So these two we are having to P3. So P3 లోకి వెళ్తుంది. So star. So in this P3 we are having three fields. So star P1 P2. So we are writing star P1 P2. So here P1 is the left child address and P2 is the right child address. So P2 is P4 P1 is the left child address, P2 is the right child address. So that is P3, and P4 we are having the two fields, so number and that particular number value P4, and we are writing next to P5. So P5 minus P3 P4. So P3 is the left child address, P4 is the right child address. Okay, then we are having P6 ID comma entry to Z. So we are converting this one to plus. So plus P5 P6. So two fields, P5 is the left child address and P6 is the right child address. Finally, this is we are naming as 7. Okay. So this is the construction of a syntax tree. So in what is the definition of syntax tree? So in a syntax tree, internal nodes are operator and the leaf nodes are operands. So finally we are constructing the syntax tree. So internal nodes are operators. So here we are having the plus. So we are having children. So the internal nodes అంటే ఏంటమ్మా? సో దోస్ ఆర్ హ్యావింగ్ ద చిల్డ్రన్స్. ఓకే, సో ప్లస్ తీసుకుంటే రెండు చిల్డ్రన్స్ వచ్చినాయి, ఇక్కడ మైనస్ తీసుకుంటే టూ చిల్డ్రన్స్ వచ్చినాయి, ఇక్కడ స్టార్ తీసుకుంటే టూ చిల్డ్రన్స్ వచ్చినాయి. సో ఫైనల్గా లీఫ్ నోట్స్ ఏమున్నాయి? ఆపరాండ్స్. సో ఆపరాండ్ ఎక్స్, ఆపరాండ్ వై అండ్ నంబర్ అండ్ ఆపరాండ్ జెడ్. సో దీస్ ఆర్ ద leaf nodes for this particular syntax tree. So this is the construction of a syntax tree. So this is another example, construction of a syntax tree for a minus 4 plus c. So we can take the screenshot, we can understand this syntax directed definition for this expression also. Is there any doubt? We can ask tomorrow. Okay. Then solve this one. Construction of a syntax tree, a minus 4 plus c. Okay. Is there any doubt with the construction of syntax tree? Any doubt?